Ife Olua. Hello, Ife Olua. Right. Okay, guys, I hope you're well. I hope you're good. Guys, we're gonna look at some factorization, okay? We're going to look at this concept of factorization because I have been getting, requests after request about please do factorization, please do factorization. So I'm gonna do factorization. Spend some time doing some factorization. So I hope you guys are down for some factorization. Please let me know in the comment section if that does not suit. Okay, so let me just share this out to some people. Okay. Factorization. Okay. People are asking for me to do factorization, so I'll do factorization. Okay. So guys, factorization, okay, what is it? It's basically factorization is the opposite process or the reverse process of expanding or multiplying. Okay, factorization is the opposite or the reverse process of multiplying or expanding brackets. Okay, and then in any factorization that you do, whatever it is, any factorization that you do, the first step is to look for a highest common factor. It's to look for a highest common factor. Okay, so I just want to say that out from the beginning, that factorization is the opposite process of expanding or multiplying, and then in any factorization the first step is to look for the highest common factor. Now, some of you may have heard me say that when you talk about highest common factor, you must talk about highest common factor according to three things, right? Okay, so the word high means biggest. Okay, C, common, means the same, and factor, a factor is a number that goes into another number, fits into it perfectly, and does not leave a remainder. So we are talking about the highest number that is the same for everything, for every term, that fits in perfectly into all the numbers in your expression without leaving a remainder. So when we take out the highest common factor, we must first take it out according to three things. One, we talk about the highest common factor sign. And when we say sign, we mean either positive or negative. So the thing is, the highest common factor sign is if the first term is positive then you are going to take out a positive sign as a highest common factor. If the first term is positive, take out positive. All right, and inside the bracket, nothing, no sign changes. No sign changes. Taking out a positive does not affect the signs inside the bracket. Okay, so if you take out a first term, I mean, if the first term of your expression is positive, you must take out a positive sign, and then inside the bracket, what you have left over inside the bracket, there's no signs that change. All the terms will still have the same sign that they had originally. So taking out a positive does not change anything, but taking out a negative when the first term is negative will lead to what? Will lead to the terms changing inside the bracket. It will lead to a sign change inside our bracket. Okay, so these are very important things to note, guys. Very, very important. Okay, so what I'm saying from the beginning is that when you are factorizing, the first step you need to take is take out the highest common factor. When you take out the highest common factor, we need to consider first the highest common factor sign, which is always the sign of the first term. So if you take out a positive, because the first term is positive, you take it out, and what you leave inside will still have the same signs that the expression had originally. But if you take out a negative, because the first term is negative, then of course taking out a negative sign will lead to a change in sign inside the brackets. So this is important about our sign. Let's move on to the next thing. Then we talk about the highest common factor number. This is simply your highest common factor for the numbers that are in your terms. Okay, and highest common factor number, you should be able to find the highest common factor of numbers that have 1, okay, that have a highest common factor. Then lastly, we talk about the highest common factor letter or variable. This is the common variable or letter which has, it's a common variable for all terms, because for it to be regarded as the highest common factor, the variable must be common for all terms, but it is the one which has the lowest exponent. Okay, so these are the 3 important things that you consider when you take out the highest common factor: the sign, the number, the letter. So when I say S and L, okay, when I say S and L, I simply mean S sign, N number, L letter or the alphabetical letter, which is a variable. But for the sign, it's always the sign of the first term of your expression. For the number, it's the highest common factor number between the numerical coefficient terms. And then lastly, the highest common letter variable or letter is the common variable for all terms which has the lowest exponent. I also want to add B, S and LB, because B means a bracket. In some instances, we have a highest common factor bracket, okay, which is the common bracket for all the terms. Common bracket for all terms which has the highest, sorry, not the highest, the lowest exponent. So when you are thinking of highest common factor, for the exponent that's there, you are thinking of the lowest exponent. That is true for when you are taking out the highest common factor variable or the letter. It is the common variable for all terms which has the lowest exponent. This is also true for your highest common factor bracket, because it is the common bracket possessing for all terms the exponent with the lowest exponent that is there. So these are things that you need to know, that when you take out the highest common factor, you take out the highest common factor sign, which is the sign of the first term in your expression, highest common factor number, which is the highest common factor between the numbers of the terms in your expression, the coefficients, highest common factor letter, which is the common variable for all terms which has the lowest exponent. And then lastly, the highest common factor bracket, which is the highest common bracket, the common bracket for all the terms which has the lowest exponent. So this, guys, is the important thing you need to note about your highest common factor. Okay, so I hope from that we can now jump into a few examples and you guys can follow along. So let us say we are given a question and it says, let's start from the basic, factorize fully, and then they say 5m cubed minus 10m squared. So what do we then do with an expression of this nature when we are asked to factorize fully? 5m cubed minus 10m squared. The question says factorize fully. So what then do you do? Very true. You look at the expression, and the question I love having learners answer before they jump into highest common factor. I usually say to them, guys, how many terms do you see in the expression? It's important to have an awareness of the number of terms you have in the expression. So this is a common question I usually say learners need to ask themselves before they jump into anything. I call these the golden rules of factorization. The golden rules of factorization. So step number one, you ask yourself how many terms. So if you look at the expression, the question you need to ask and then answer is how many terms do you have in this expression? So I'll await your answer in the comment section, and then when you have answered, I will proceed to the next question. How many terms are in the expression? Hopefully by now we know that we count terms, right, as they are separated by a plus or a minus sign. So how many terms are there? So yes, the grand jury answers that there are 2 terms, and it's true, there are 2 terms. Okay, we answer that question, we move on to the next question. SCR, do we need to apply the sign change rule? Do we need to apply the sign change rule in this expression? Guys, the sign change rule is something that we always check in an expression before we ask about the highest common factor. The sign change rule is simply a little technique that we apply whenever there are terms in an expression and we wish to actually write these terms in a different order, yet there's a minus sign inside. All we simply do with this technique is we take out a sign that is negative, then that allows us to swap around the b and the a, so that we now have a minus b inside the bracket, which is our intention or our hope even from when we looked at the question, to change or swap around the terms because there's a minus sign in between. Taking out the negative sign makes it so that this expression retains its integrity. Take the negative sign back. What's a negative times a? You get that negative a back. What's a negative times another negative? You get that positive b back. So taking out the negative sign does not change this expression, but it simply helps us to be able to state it in such a way whereby this bracket yields what we have been looking for. So if you look at this expression, there is no need to apply the sign change rule because there is no need. So then you can move on to the third question and ask, is there a highest common factor? And then when we do identify the highest common factor, we want the three important fundamental elements that come along with that to also be identified. We want the highest common factor sign S, number N, and letter L. So we want the highest common factor sign. So we look at the first term and we look at it and we look at this and we say, what the first term? Is it positive or negative? We can clearly see that the first term is positive. So our highest common factor sign is positive. We then ask the number. What is the highest common factor number between 5 and 10? Okay. What is the highest common factor number between 5 and 10? What is the highest number that goes into 5 and goes into 10 without leaving a remainder? That is what we are basically looking for as we try to identify the highest common factor number between 5 and 10. So guys, really and truly, between 5 and 10, the biggest number that goes into 5 and 10 is 5. There's no number that is bigger than 5 that goes into 5, because 5 goes into 5 once and 5 goes into 10 twice, right? There's no other number that is bigger than 5 that goes into 5 and goes into 10. So that's why we identify 5 as the highest common factor number. Then we move on to the letter. We look at the first term, we've got m cubed. Look at the last term, we've got m squared. So remember, when we said we want to identify the highest common factor letter, we look at the common variable or letter for all the terms. So we can see that m and m are common for both terms because there are two terms. So we can see the m is common, but we look for the m which has the what? The lowest exponent. Not the one that has the highest exponent, but the m that has the lowest exponent. And what is that m? So we look at m cubed, we look at m squared, and then we ask ourselves, which letter for m has the lowest exponent? Is it m cubed? Is it 3 that has the lowest exponent, or is it m squared, the 2 that has the lowest exponent? Because that will be our highest common factor letter. So that means the highest common factor letter is going to be m squared. There it is, guys. So our highest common factor is 5m squared. What we do when we have identified the highest common factor, we take it out. Take it out. Then we open brackets to indicate that 5m squared has been withdrawn from the expression. What is left now inside the bracket? 5 that is positive times what will give you 5 that is positive? That is 1. M squared, there are 2 of these m's multiplied together. At the end, we want 3 of these m's. Do we need to add any more m's? Do we need to add any more m's? If we have 3, we need 3 at the end. We have 2 that we've taken out. Is there any more m's that we need to have represented? Yes. Okay. 5m squared times the m will give us back the 5m cubed. Remember, when you take out a positive, the signs don't change. This term inside the bracket is still positive. This term, the second term inside the bracket, will still be negative. Taking out a positive does not change the signs, it retains them. 5 times what is 10? We have 2. M squared, we need m squared at the end. Do we need to add any more? No. So we are done. This m minus 2 represents what is left over after taking out 5m squared. So we have m minus 2. And we look inside the bracket and we ask ourselves, is there any further factorization that needs to be done? Any further factorization? If there is, you do it. If there's not, you don't. Okay? If there is, you do it. But if there's not any further factorization, you don't. And lastly, you ask, are there any like terms inside the bracket? And then if not, then that basically means that this is your answer. Nothing more, nothing less. Okay? That wasn't difficult, was it? So we ask any further factorization. If there is, do it. If not, stop. Okay, then are there any like terms in each bracket? Because if there are, if there is, take care of them. If there is, take care of them. Okay? Right, I hope we're together there, and I hope we are sweet, safe, and sound. Let's look at another example. Guys, I hope that example was okay for you and you guys find comfort. All right, I need all of us now, because you've been taught at your schools, I need all of us to lock in and to really make sure that we now master factorization once and for all. We can't be, guys, still wondering and doubting our factorization skills. We need to be mastering our factorization, and we must be masters over the factorization. All right, failing which, if we continue to have doubts and not be clear about factorization, it will continue to affect us very negatively in our maths experience, and that is from grade 10 going onwards. So you must decide once and for all. If it means you need to set aside something you really enjoy so that you can devote a little bit more time practicing mathematics, guys, it will be worth it at the end. All right, you may not realize it now, but it will be worth it at the end. So let's look at these terms now. Once again, we are going to factorize. So what is the first question we usually ask ourselves whenever we are about to factorize? Step number 1, we ask, how many terms in the expression? So guys, how many terms do you see in this expression? Mina kitlaulinda batu babuwe batu babaleka comment section batu ba yeah batu ba, you know, batu ba ba, you know. Okay, Liam Mkokeli says 4. There are 4 terms in the expression, Liam. 2a squared b plus 3a squared b squared minus 5abc. That is it. So you are saying in this expression, when you count, you're remembering that terms are separated by a plus and a minus sign. So when you are counting, you are saying you are seeing 4 terms. Plus and minus separating the terms, you count and you are like, I see 4 terms. Okay, and Inakondambana says 3. Right, I think we are closer to the truth than Liema there. So Endinako, you are correct. There are 2a squared b is 1 term. Remember, a squared b and 2 are combined because of multiplication. Okay, if you were to see what's here, you would actually see 2 times a squared times b. That is basically what keeps the 2 and the a squared and the b together. multiplication is like glue that holds coefficients and variables in a horizontal, I would say basically they hold 2a squared and b in a horizontal hostage. All right, that's what multiplication does. It holds 2a squared and b in a horizontal hostage. They are held hostage together, you know, combined, joined at the hip. That's one term. Then plus, unlike multiply that combines, plus separates. So that's why we count 1, then plus, then we have 3a squared b squared. That's 2. Okay, remember what keeps 3a squared and b squared together? It is multiply. It holds 3a squared b squared hostage. Minus separates. We have 5abc. So that's why we say there's 1 plus 2 minus 3. There are 3 terms. Please guys, let us not miscount the number of terms. Even that for me is a very red flag for a maths learner, to not be able to count the number of terms. Yet in grade 8 and 9 you guys focused on expressions and counting terms, yet you still can't count. Hi guys, you see, some of us we are not kind to ourselves. Please let's fix that. So let's look at the terms. We ask ourselves now the next question: do we need to apply the sign change rule to the expression? Is there a need to apply the sign change rule in this expression? Okay, remember what I said about the sign change rule. It's designed to actually make brackets to be the same, especially when there's a minus in between 2 terms and we wish to have the order be different. We wish to have the opposite order, a minus b, so we take out a negative sign and then we reframe the expression. So is there a need to do that here? No. 3, highest common factor. We want to now take out the highest common factor according to the sign, the number, and the letter. So the first term is positive, so that means highest common factor sign we have is positive. We move on to the next thing, the number 2, 3, and b. Is there a need? No guys, 2, 3, and b, nothing is common. We move on to the letter a squared. Let's start with the a's. A squared, a squared, a. What is the highest common factor between a squared and another a squared and an a? Okay, what did we say about the common variable or the highest common factor variable? It is the common variable for all terms which has the lowest exponent. Is the a available for all terms? Yes. Which one possesses the lowest exponent? It is a. So we take out a, and remember, before the a there's a positive one which you cannot see, which is also out there. Then we move on to b. B squared, and b. Which one is the highest common factor between b squared, and b? We take out the common base that possesses the what? The lowest exponent. So what is that? Who do we take out, guys? Okay, hopefully you know we take out b. Yes. Then lastly, we can see that there is a letter c, but it's only there for the last term. So is there a need now to take out c as a common factor? Is there? Is c common for all 3 terms? Should we be taking c out as well? Let me see what you guys say in the comment section. Should I be taking out the letter c as the highest common factor there? Kevia Chris, definitely not. So we don't take out. So that means we are done with the highest common factor. We open the bracket and then now we write what is left over. For the first term, we took out a and b, one of the a's and one of the b's. At the end I have 2. Do I need to add any more a's? B was taken out. I have a b. Do I need to add any more b's? 2 is the result. I took out 1. Do I need to put the 2 in there as well? So I'm sure you guys can answer that. See that the answer is 2a, and then obviously the b is not going to be put in there because we have already taken it outside. we move on to the next term. We write plus. 1 times what is 3? So the 3 is still intact. A times what is A? Took out 1A. I need 2 of them. Do I need to add any more? Yes, I need to add 1. B was A. B was taken out. I need 2. So I need to also add 1. So therefore the leftovers inside this bracket are 3AB, and then the very last term, remember there were 3. I answered that question, so I'm expecting to have 3 terms inside the bracket. A was taken out. A was what was basically at the end. B was taken out. B was what is at the end. C I did not take out, so that means I'm left with negative 5C. Don't forget the negative sign. Then from here, can we factorize these 3 terms any further? The answer is no. So therefore we end right there and we dare not continue any further. Okay, so the signs are the same inside the bracket because I took out a positive. Whenever you take out a positive, the signs don't change. If the first term that is taken out is positive, you take it out, and then inside the bracket, no sign changes at all. The signs basically that you had are the ones that you have inside the bracket for each term. Then, if the sign for the first term, x squared, is negative, then the first term will lead to the sign changing inside the bracket. Okay. Okay, so I hope that makes sense. Magai, grade 8B. Nice for you. All right, let's move right along then to the next question, number 3. So number 3 says A into M minus N plus B into N minus M. So let's look at this question. Sorry, what am I saying here? Okay, let me just rewrite this. A into M minus N minus B into M minus N. My bad, guys. Just quite a bit carried up here. Okay, let's look at this expression. Okay, so the first question, so let's first look at it. We have A into M minus N minus B into M minus N. First question you ask is how many terms are in the expression? Let's see in the comment section if we can answer this. How many terms are there in the expression? How many terms do we have in the expression? Okay, my guy, thank you. Dombana, thank you so much. Nice to see you answer there in the comment section. There are 2. Yes, very good. There are 2 terms. Yes, Liam. There are 2 terms in the expression. Why do we say 2? Remember, A and your bracket make this 1 term. The A into M minus N makes this become 1. The minus sign then separates the B into M minus N. The bracket that is attached to B make this 1 term. So we have how many terms in the expression? 1. Okay. The minus sign separates. The B into M minus N is 2. So we have 2 terms in the expression. Very good. The next question we ask, is there a need to apply the sign change rule? So let us first check, because here this time round we have brackets in the mix. So what we want to check is M minus N here and M minus N there. Do they need any touch from us of the sign change rule? Well, the brackets are common, so there's no need for the sign change rule here, because it's not like the order here is twisted. So then we proceed further. Next question, is there a highest common factor? So when you take out the highest common factor, remember I said we take out the highest common factor sign, which means the first term has a coefficient of 1 that is positive, so we know that we take out positive. number will be 1, because here before A we have the number 1 and before B we have -1. So we take out 1 as the highest common factor. 2, the letter A and B are not common, so we move on. There's no common letter. And lastly, the bracket. Okay, S and L, B. Don't forget, sometimes there's a common bracket that we take out. So the question is, for these two terms, what bracket is common? It's evidently m minus n. We take that out, then we write what is left over. If you take out m minus n for your first term, what is left on your right, on your left? A. If you take out m minus n for your second term, what is left on the right? Negative b. If you look at each bracket, is there any further factorization or simplification that needs to be done in each bracket? The answer is no. So that means we end our factorization process right there at m minus n into a minus b. And then we end just there. Okay, right? So hopefully we can see that this thing, there's nothing in this thing called factorization. It's just that we make a fuss out of it, and it ends up being a fussy affair when it does not need to be. So let's look at another factorization question. If it says factorize fully here, we have 3x into 2a minus 1 minus 5 into 1 minus 2a. So the question says factorize. But as we proceed and as we consider factorization, what is the first question we always ask ourselves just before we go about and factorize? Well, we first look at the expression. This is 3x, so that we can be aware of what is there. This is 3x followed by a bracket. There's a 2a minus 1 inside this bracket. This is negative 5 followed by a bracket. There is a 1 minus 2a in this bracket, and it's closed. So we are aware of the expression and what it possesses. So then we can now ask the first question we usually ask when we are factorizing, and that is, how many terms are in the expression? So if you look at this expression, grade 10s, how many terms do you see in this expression? How many terms are in the expression, grade 10s? How many terms are in the expression here? You spent some time first before you asked this question. You looked at 3 and the x. You looked at there's a bracket. You saw there's 2a minus 1, the closed bracket. You saw there's minus 5 into 1 minus 2a, the other bracket. So how many terms in the expression? Endinako, very good. Liema, very good. You see, now we are answering. You can see the focus is on. People are locked in. Yes, we are answering correctly. No mistakes in our answering, because we are aware of what we are being asked. And it's about time that we stopped playing victim and start claiming our appropriate position of understanding of factorization. So there are two terms. That's true. Next question. The second question we always ask is, do we need to apply the sign change rule in this particular expression? Is there a need to apply the sign change rule? Yes or no? In the comment section. Is there a need to apply the sign change rule? Look at your first term. Look at what is inside the bracket. Look at your second term. Look at what is inside the bracket. Do you see a need that we should apply the sign change rule? And remember, what did I say the sign change rule is? It is that rule where if you have an expression and your desire is that this expression, the A comes first, the B comes second, then what you do is you take out a negative sign and you change the order of the B and the A to become A minus B. Because you know very well, that a b minus a is not the same thing as a minus b. Just like you know that 1 minus 2 is not the same thing as 2 minus 1. It does not give you the same answer, because in grade 8 you learned that subtraction is not commutative, right? Subtraction is not commutative, right? So if you look at this, is 2a minus 1 the same thing as 1 minus 2a? Is it, guys? Just like I could ask you, is 1 minus 2 the same thing as 2 minus 1? Is this 2a minus 1 the same thing as 1 minus 2a? Is it? Okay, clearly, guys, it's nope, right? So what we do then is we apply the sign chain rule. That's why this question is so important, that you must ask, yeah, All right, we're back, guys. Sorry about that. Just received a call here, so I couldn't really do that multitask. Okay, so here 3x into 2a minus 1 minus 5 into 1 minus 2a. I think we've answered the first question, right? How many terms? There are 2. Second question, is there a need to apply the sign change rule in this particular expression? Well, we can clearly see that there is a need. Why? Because this 2a minus 1, it's so close to becoming a common bracket with this. Currently it's not, but it can be, right? This common bracket, this bracket can be common with this one for this term, if only we can apply the sign change rule for this term. So what we do then is we write 3x into 2a minus 1. And then what do we do to the negative 5, guys? Because we are now applying the sign change rule. Remember, typically we take out a negative sign. If we take out a negative sign, what effect does it have on this negative sign? Remember, we take out a negative sign. Remember the sign change rule, b minus a, you can write it as you take out the negative sign and then you swap the order of the letters. Okay, yeah. So if I take out a negative sign for negative 5, what happens to a negative times another negative? It becomes positive. Then what happens here? 2a minus 1. Now my expression, oh, my expression is sweet and sound. Now my expression is doing the things. Okay, so now I relook at this expression again. All right, and when I relook at it, I ask myself now, is there a highest common factor? And remember, when I take about highest common factor, I'm talking about the sign, the number, the letter, the bracket. The sign, the number, the letter, the bracket. So when I think about sign, I'm thinking of the sign of the first term. It's positive, so my highest common factor sign is positive. When I think about number, guys, I'm looking at the number coefficient before the bracket. That's what I'm thinking about when I think about the highest common factor number between 3 and 5. Obviously, it is going to be 1. The highest common factor letter, now we are looking specifically at the variable outside the bracket. When you think about highest common factor letter, we are not talking about the letter inside the bracket. No, we are talking about the letters outside the bracket. The variable coefficient, if you want to call it that, because it's the letter that comes before the bracket. The letter, which is not here in this case, that comes before the bracket. So is there a highest common factor letter? Is there a variable that is common? Okay, x is alone here. Here, there is no other letter or x or anything of that matter. So do we have a highest common factor letter? Seems like we don't, guys. We don't have a highest common factor letter. That common variable with the lowest exponent, because x is not common for both terms. Then we look at highest common factor bracket. Okay, the common bracket with the lowest exponent. So that means 2a minus 1 is that bracket. So when we take out the highest common factor, what are we taking out? 2a minus 1 in brackets. That is a positive 1 2a into a minus, in positive bracket 2a minus 1. This plus 1, I usually call this the unseen. All right, for me it's like God, not seen or visible, but the positive one. You know, you would think that this 2a minus 1 is alone, but it's not alone. Just like, you know, we think that we are alone in life, but we are not. You know, there is a spiritual presence around us, in us, about us, if you want to call it that. And it can either be good or bad. It can be positive or negative. So in this situation, the positive one, I tend to say to my learners, it is like the positive, unseen God that we know is present and is ever present, omnipresent. So we take out then the common bracket 2a minus 1. When we take out 2a minus 1, what gets left over on the left side of the term? If we take out 2a minus 1, what gets left over, guys? What is remaining on this side? It is 3x, all of it. Then 2a minus 1 taken out, obviously. Here, what's left over for the second term? It is positive 5, obviously. Then we ask ourselves, inside each bracket, can we factorize or simplify any further? No. Any like terms that you see in each bracket that need to be added or subtracted? No. So therefore we end right there. That is basically our factorization done and complete. Okay. Hi guys, I hope we are clear. I hope we can see the light. Okay. I hope we can see the light and the sunshine. Yeah, Ibo. Okay. I don't know if there's any questions that people have. Hopefully we are clear as daylight. Okay. Okay. Now we are going to move on and look at another type of factorization. Okay, we've initially started with highest common factor. We are going to look at another type of factorization that we call a difference of two squares. And as we look at it, what I want you to note, guys, is that one, to spot a difference, okay, or what I call DOTS, okay, for short, difference of two squares. To spot it, these are the things you need to take note of. One, it consists of two terms. So be always alert and awake whenever you have an expression and it has two terms. So one, it consists of two terms. Okay, difference of two squares consists of two terms. Okay, two, okay, terms have different signs. Usually the terms that are there have different signs. Okay, one will be positive, you know, in your terms, and the other one will be negative. Okay, then three, the last and final thing to always check, each term, okay, is a perfect square. Now I need you guys to know and be aware of what a perfect square is. Perfect squares are noticeable in numbers, in letters, and in brackets. Perfect squares are noticeable in numbers, all right, and we are going to look at what do we mean by perfect square numbers. Perfect, so I'm going to call them PS numbers. The PS means perfect square. For your numbers, how do we identify a perfect square number? Guys, a PS number or a perfect square number is a number that is attained by multiplying a natural number by itself. And some of you are like, natural number? What are you talking about? Say natural number. Guys, we know what natural numbers are. Okay, do you still remember what a natural number is? Natural number is a number that starts at 1. Okay, all those family of numbers that start at 1, increase by 1 to infinity, those are natural numbers. So perfect square numbers, guys, are numbers like 1 is a perfect square number, 4 is a perfect square number, 9 is a perfect square number, 16 is a perfect square number, 25 is a perfect square number, 36 is a perfect square number, 49 is a perfect square number. Do you guys want to give me the rest up until 100? 1 is a perfect square number. Why? Because it is 1 times 1 that basically forms 1. So we call 1 a perfect square number. 4 is also a perfect square number because it is 2 times 2 that actually forms your 4. So we say 4 is a perfect square number. 9 is a perfect square number. Why? Because it's 3 times 3 that forms 9. 16 is a perfect square number because it's 4 times 4 that forms 16. All right? So that's why we say perfect square numbers are numbers that are formed by multiplying a natural number, a particular natural number by itself. If you do that, you'll get a perfect square number. 25 is a perfect square number, 36 is a perfect square number, 49 is a perfect square number, 81 is a perfect square number, and 100 is a perfect square number. Why, guys? Because all of these numbers, when multiplying a certain natural number by itself, these are the numbers that you get. We call these perfect square numbers. Okay, hope we get that. So that is for our numbers. They are obviously more than the ones I've just highlighted. It's just noteworthy to note the perfect square number and how it is formed. A number attained, or a number that is formed, a number attained or formed by multiplying a natural number by itself. That is a perfect square number. Now let's move on to the letter. What is a perfect square variable or letter? A perfect square variable or letter, guys, is a PS letter or a PS variable is a variable raised to an even exponent. Any variable, guys, any letter of the alphabet, the minute it is raised to an even number exponent, then we call that a perfect square variable. So for instance, your examples are, a squared, the perfect square variable into it, c to the power 6. The c is a letter, the exponent is an even number, so this qualifies as a perfect square variable. Z to the power 8, a perfect square variable into it. Right? You can think of many others. X to the power 12. All right, guys, the list is endless. All right, you could basically take any letter, the minute you raise it to an even exponent, then you call that a perfect square variable. Then let's look at the PS bracket, because you think that perfect squares are limited to numbers and letters. Well, got a surprise for you. Perfect square brackets, a bracket raised to an even number exponent. Any bracket raised to an even number exponent, for instance, x plus 2, the whole thing squared, the expression is raised to the power 2. We call this a perfect square bracket. A plus b, the whole thing squared, is a perfect square bracket. X plus minus 3, the whole thing to the power 4, could be to the power 6. The minute the base expression is raised to an even exponent, we call it a perfect square bracket. So please, guys, remember what I said. To spot a difference of two squares, what do you need to do? The expression must consist first of two terms. That's number one. 2, the terms must have different signs. And then lastly, each term must be a perfect square. And now I've just given you an idea that a perfect square number is simply a number attained or formed by multiplying a natural number by itself. And I've given you examples of perfect square numbers that we can think of. A perfect square letter or variable is a variable raised to an even number exponent, like such. Okay, See these letters, they all have even number exponents. Guys, if the variable has an odd number exponent, it is no longer a perfect square letter. Then lastly, a perfect square bracket is a bracket raised to an even number exponent. For example, you can see here x plus 2 in brackets, the whole thing squared. That means that's a perfect square bracket. And so is a plus b, the whole thing squared. And so is x minus 3, the whole thing to the power 4. So all of these are perfect square variables here, letters, and perfect square brackets. I hope we are so clear as daylight and clear as can be. Okay, so let us now look at an example. If we are required to factorize fully, let's say the following: a squared x squared minus b squared. All right, sorry guys, I was wondering why is there a funny face popping up every single time. I see there's an effect that I put into display without even thinking. Kanwala. So a squared x squared minus b squared, factorize fully. Okay, so first things first, we ask the typical question: how many terms in the expression? If you look at the terms that we have in the expression, how many do we have? We have how many terms, guys, in this expression? Because we always need to go through the list of questions. Hopefully we can see the expression. We can see this is a squared x squared minus b squared. And in Ako, very good, we have 2 terms in the expression. 1, 2. Second question, is there a need to apply the sign change rule? Do we need to apply the sign change rule in this expression? Is there a need? Yes or no? Okay, it's either I am alone in this live or people are, I don't know. Okay, not responding. It's very quiet. Okay, no. Okay, it seems like Endinako is the only one that's actually responding. Thank you, Endinako. So there is no need to apply the sign change rule. Next question. Is there a highest common factor? So if we look at this, is there a highest common factor in the expression? Okay, highest common factor sign, positive. Highest common factor number, 1. Highest common factor letter, no letter. Highest common factor bracket, no bracket. So all in all, what we have is 1. 1, guys, is the highest common factor. We leave a squared x squared minus b squared. Now I know for some people they're going to be like, I will say, I mean, taking out the 1, really? Well, you know what, guys, when I take out the highest common factor, what that does, it actually makes what I see as 2 terms actually become 1 term. Okay, so that 1, okay, not necessarily even writing it down, but just putting the brackets makes 2 terms become 1 term. Now you look inside the bracket. Is there any further factorization that can be applied? Most of you may take for granted this taking out of a highest common factor, but let me just say to you, it's so important. If you look at a squared x squared minus b squared, all right, does it consist of 2 terms? Yes, it does. Inside the bracket we have 2 terms. 2. Do terms have different signs? This term is positive, this term is negative. Yes, it does. Does each term show a perfect square? Is each term a perfect square? So let's look at A. A is raised to an even exponent. Any letter or variable raised to an even exponent is what we call a perfect square variable. So a squared is a perfect square variable. What about x squared? As well, x squared is a perfect square variable because this is a variable raised to an even exponent. So our first term is a perfect square. Let's look at b squared. What about b squared? Is it a perfect square variable? Yes, a variable raised to an even number exponent is a perfect square variable. So what do we then have in this bracket? We have a difference of two perfect square terms. So then what do we do when we factorize a difference of two perfect squares? Well, step number one, we open two brackets. That is the first step, open two brackets. Once you have concluded and you've arrived at the decision that one, there are two terms have different signs, three, each term in the expression is a perfect square, then you can go ahead and you can open two brackets. 1, 2, put a plus in the first bracket and then a minus in the second bracket. Put a plus in the first bracket, put a minus in the second bracket. I always endorse putting the sign first. Put the signs first. A plus in the first, a minus in the second. Someone else will be like, so does it matter if whether I put a plus sign or a minus sign first or a minus and a plus? Doesn't matter, guys. But I usually encourage learners to put the plus first, then the minus last. Okay? Just in case there's another difference of two squares that pops up for the last bracket and you have to open two additional brackets. Rather, open the other two additional brackets at the end of your plus bracket. Does that make sense? Anyways, now a squared and x squared, what we do is we take the square root of a squared x squared. Take the square root. 3. After putting plus and minus, take what? E square root of each term. Take the square root of each term. So remember here in grade 8, we had a rule that whenever you have a multiplication of bases, you can split them bases. So the a squared and the x squared can be split. And then if I apply the square root to the a squared, it means this exponent 2 divided by the 2, which represents the square root. What does that give you? A, where do I put it? A. What about the square root of x squared? Same thing. X to the power 2, this 2, over 2 to remove the square root, which is x. X to the power 1. So we say x and x next to the a, because remember a squared x squared were one term together multiplied to each other, so the resulting answer is ax. So it's ax as the first term of each bracket. Then lastly, you take the square root of b squared, which is the second term in the expression. Then that becomes b 2 divided by 2, which is b. Okay, remember, for some people it's a matter of when you apply the square root to the square and the square root cancel each other. In other words, 2 divided by 2 is 1, which basically leaves us with b. So then we have b and b. When we are done, we look at ax plus b in this bracket. Can we factorize further? No. Are there any like terms? No. So that means we end there for this bracket. We look at this bracket. Can we factorize further? No. Are there any like terms? No. That means that is the end of our factorization. Difference of two squares factorization is done in this fashion. Okay. So let's move on to another great example. X squared minus 9. X squared minus 9. So we look at the expression again, and guys, we go through the step-by-step process of actually getting to factorize. We don't rush, we just go through the process mentally so that we can capture what is happening. Look at the expression, identify what you see. This is an x squared, this is a minus, this is a 9. Already that's telling you a lot. So you ask your first question, and that is how many terms are in the expression? How many terms do you see, guys, in this expression? You just need to answer the question once. How many terms are in this expression? There are 2. Very good. Then you ask the next question. Is there a need to apply the sign change rule in this expression of 2 terms? Guys, there's no need because there are no brackets, so we're not trying to make anything common where there's a minus sign with common brackets for 2 terms, so no. Step number 3, is there a highest common factor between your 2 terms? Is there a highest common factor, sign, number, letter, or bracket? Here we see there's a positive term. So of course, guys, if this is a positive term, we know that the positive sign is taken out as a highest common factor. Then there is a coefficient of 1 that we don't see here, and this is a 9. So between 1 and 9, what is the highest common factor? Guys, it is that positive one that I was talking about, the unseen God that I was talking about. So if you want to, God is positive, guys, good all the time, positive all the time. So it is that highest common factor. So if we think about it, that is the highest common factor, sign, number. There is no letter that is common. So we can simply write x squared minus 9 in brackets. And I basically really think this is important, okay? I know some of you go straight to the point, but I think this is important to first acknowledge that taking out the highest common factor in my factorization is of importance. Why? After having taken out the highest common factor, I can now look inside this bracket and ask myself, what else is there? Is there any other type of factorization that can be done with what is inside? So please, guys, take note. I will then go and check, is dots or difference of 2 squares satisfied in that expression inside the bracket? 1, do I have 2 terms inside that bracket? Yes, I do. X squared minus 9. These are 2 terms inside the bracket. 2, do terms have different signs? Yes, x squared is positive while 9 is negative. So terms do have different signs. 3, does each term exhibit a perfect square? Does each term exhibit a perfect square? Yes, guys, this is x squared, and I said any variable raised to an even power exponent is a perfect square. So x squared is a perfect square. What about 9? Is 9 a perfect square? Well, we said perfect square numbers are numbers that are attained or formed by multiplying a certain natural number by itself. So 9 is a perfect square. If these 3 conditions are met, then it means that this is a difference. I say again, difference. Why are we saying difference? Because there's a minus sign in between. A difference of 2 perfect squares. So then what do I do if I identify this as a difference of 2 squares? Step number 1, open 2 brackets. So I'll do that. Step number 2, put a plus and a minus sign. A plus sign in the first bracket, a minus sign in the second bracket. Plus, minus. Step number 3, take the square root of each term, because you've established that the 2 terms are perfect squares, right? So you take the square root of each term. Take the square root of each term. So we're going to say the square root of x squared is what? I know most of you know this already, guys, but I'm just explaining this out for those that want to see what it is that we do. So obviously this is x2 over 2, and obviously 2 divided by 2 in the exponent is 1. Therefore we write x and x, because the square root of x squared gives us x and x. Then what about the square root of 9? The square root of 9. The square root of 9 is 3. So then what do? We write 3 and 3 in the second position, or the second term of each bracket. We look at each bracket and we ask ourselves, are there any like terms in each bracket? No. do we need to factorize any further for each bracket? It's obviously no. Thank you so much, Jackson. I really appreciate the rose. First gift of the live of the day. Thank you. Okay, thank you. Right. Final answer, guys. X plus 3 into x minus 3. Woni, why are you playing victim in my comment section? Ignore me, actually. My answers are wrong. Why are you playing the victim? Woni, there are three kinds of people in life. There are those that they wait for things to happen. All right. 2, there are those that basically wonder what happened. And then 3, there are those that make things happen. So you playing victim in my comment section is not going to help you in any way. All right. Yeah, you could see that I'm busy explaining a question. Now you are typing there and you are playing victim. Ignore me, actually, my answers are wrong. And then you are boo-hoo-hooing it in the comment section. Woni, that's not the way to go. All right. I want to actually invite you to become someone that is a bit more assertive and someone who is a bit more no playing the victim card. That doesn't help anything in life. Okay. Yeah. So you could see I was explaining the question, and maybe what you could have done is actually listen to the example. No, you weren't trying to be mean, but your comment, ignore me, actually, my answers are wrong. To me, that sounds like playing victim. Okay, it does sound like playing victim because you are saying ignore me, actually. Why? Ignore me, actually, my answers are wrong. No. Woni, you are playing victim. Okay, at least it sounds like that from my end. Okay. Rather, if you look at the question that you typed, you said x squared minus 81, right? So if you look at that x squared minus 81, let's follow the process. Have you been listening to what I've been saying, or have you been too keyed into the question that you've typed in the comment section? Because if you've been paying attention to what I've been saying, then you would have seen that your question that you are asking can also be factorized. All right, it can be factorized just as well. All right, so let's look at the question. So since you have typed it, let's look at it. You first typed x squared plus 81. All right, now Woni, let's look at x squared plus 81 because this is what you first typed in the beginning. Okay, because I want to clarify something by using what you typed in the comment section. So we have x squared plus 81. All right, first question we ask whenever we're about to factorize something is we first ask ourselves, how many terms in the expression? So Woni, yeah, you can take back your authority, all right, and be assertive and answer me that question. How many terms are in this expression? Now I'm going to wait for your comment, and I'm going to wait for all your comments step by step. I'm not going to move to the next step until you answer me. Okay, thank you, Woni. There are 2 terms in this expression. Well answered. Let's look at the next question. The next question that we usually ask ourselves is one that has to do with what we call the sign change rule. We ask, is there a need? Do we need to apply the sign change rule in this particular expression? Is there a need to apply the sign change rule? Woni. Okay. Is there a need to apply the sign change rule, Woni? Lone Wolf, can you leave Woni alone? Woni needs to concentrate here. Please, Lone Wolf. Okay. There's no need. Thank you so much. Woni, there is no need to apply the sign change rule because the sign change rule, when is the sign change rule applied? Woni, I'm sure you can see this question. Okay. If I was to ask how many terms are in this expression, Woni, you would tell me, I hope, that there are how many terms. I'm talking about this expression specifically. How many terms are in this expression? And maybe you will see why we usually say this thing of how many terms do we need to apply, and then immediately thereafter we ask, is there a need to apply the sign change rule? Okay, so in this expression, Woni, yes, there are 2 terms. You are correct, Woni. 3x into 2a minus 1 qualifies as 1 term. You have a minus sign which separates, and this is 2 terms. After answering that question, the next immediate question we ask, is there a need to apply the sign change rule for this expression? Now, Woni, I hope you would answer Because when you talk about sign change rule, you look at the brackets. This is 2a minus 1. This is 1 minus 2a. Are these the same? No, they are not. Therefore, for this term, you change the sign of the coefficient of the bracket. You change the order of the terms. That is applying the SCR, sign change rule. Why? So that you can have a common bracket. Okay, and then you see once you take out that common bracket and you get left with 3x plus 5. The factorization is complete. That's done. So that's why we always ask that question after asking how many terms there are. Woni, I hope you are with me. I hope we are flowing together so far. Okay, you see, so how many terms? You said 2. You answered very well. Number 2, do we need to apply the sign change rule? You answered and you said you don't think so. Well, you know what? Now you don't have to say, you know, maybe you don't think so, whatever. Sorry. What? Yeah, you said I don't think so. You thought well. You thought very well. You thought very well. Okay. Then the third question: is there a highest common factor between x squared and 81? Is there a highest common factor? And I said to you guys that when you take out the highest common factor, you must take out the sign first, then the number, then the letter, and the bracket if there is one. Highest common factor, sign, number, letter. So to you, I will say, Woni, you know, contrary to popular belief, there is a highest common factor. And if we say what is the highest common factor, sign, number, and letter, okay, the S, the sign that we take out is going to be a positive sign. Why? Because the first term, the sign of the first term, we regard as the sign of the highest common factor that we take out. Then we are going to compare 1 and 81. What is the highest common factor between 1 and 81? It is 1. Then letter. Is there a highest common factor letter? Well, x squared is only available for the first term. There's no letter for the second term. So we don't have a highest common factor letter. Thank you, Gabby, for the rose. Gabby Malose, thank you so much. Watong, I really appreciate you, brother. Because, it's been hard to come by these roses. Thank you so much. Really appreciate it. That's 2 out of 1,000 roses. Really appreciate it. I think we can really appreciate the kindness when it does come. Okay, thank you guys. Appreciate all gifts that come, whatever it is, whatever you can. I really appreciate it. Then highest common factor letter, x is not common, so there's no letter. Then bracket, there's no bracket that is common. So basically our highest common factor is 1. I can take it out, and then what gets left behind? It's x squared plus 81. Guys, from 2 terms in your expression, factorization makes it so that now we have 1 term. This was initially 2 terms, but now it's 1 term. Then the next question you want to ask, since we've taken out the highest common factor 1, some people would even not write the 1 outside, because remember guys, the positive 1 is like the God that we serve. God is good all the time, right? All positive, you know, and it's good all the time. So we say x squared plus 81. That 1 we don't have to write there, but this now, x squared plus 81, is now in brackets, guys, and that is factorized as far as we can. If you look at this, this is a sum of 2 squares. X squared is a perfect square, 81 is a perfect square, but this is a sum. Guys, this is not a difference of 2 squares. Remember, what are the conditions for a difference of 2 squares? Firstly, 1, to spot a difference of 2 squares, the terms must be, there must be 2 terms. Okay, so inside this bracket, yes, we do have 2 terms. The second thing is that the terms must have a different sign. Look at the first term. How is it? It's positive. Look at 81. How is it? It's positive. Do the terms have different signs? Answer me that question, guys. Do the terms inside the bracket, x squared and 81, have different signs? Do we know what different is? They are not the same, the signs. Are the signs for the terms, x squared is positive, 81 is positive. Do the terms have different signs? Okay, no. Thank you. Thank you so much. No, 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 no. No, they don't. So therefore, you see now, when we are saying to spot a difference of two squares, they must consist of two terms. Yes, this is two terms inside the bracket. Two, the terms must have different signs. You see, that's where we stop. These terms don't have different signs. So therefore, this is not a difference of two squares. Does each term consist of a perfect square though? Does each term have a perfect square? Is x squared a perfect square, guys, and is 81 a perfect square? So if you are saying both terms are perfect squares, you can say yes, they are perfect squares. But if you are saying one is not, you can say no. Okay, Woni, I am looking for you to answer. Woni, I'm always looking out for Woni. Woni, thank you so much. So Woni is also saying yes, x squared and 81 are perfect squares. But you see, the thing is, we cannot factorize this any further. Why? Because it is not a difference of two squares. So we stop right there. The answer is x squared plus 81 just in brackets. From two terms, we have one term, and we stop right there. We cannot factorize any further. Woni, are you with me? A sum of two squares, a sum of perfect squares, we don't factorize. We can't go any further here than just writing x squared plus 81 in brackets. That is as far as our factorization can go. All right. Now I'm going to go to the question now that you almost said that Now you then typed another question in your comments in the comment section, and you said x squared minus 81. Remember that one? You changed plus and you changed it to minus. So let's look at this one now. I'm going to go through the same process. What is the first question I ask when I'm about to factorize? Doesn't matter what it is. I first ask myself what? What is the first question? Diputso yakukhala yokukhala is how many terms? Thank you, Liam. How many terms? So how many terms do we have here? Tell me. You tell me how many terms we have. How many terms, guys, do we have in the expression? 2. Thank you so much. When Woni answers, guys, it means the rest of the crew is also answering correctly. We have 2 terms in this expression. Okay. Next question. Is there a need to apply the sign change rule in this expression? Okay. Do we need to apply SCR? They talk about procedures in medicine. CPR. When someone is choking, you apply CPR. Or someone has lost breath, you apply CPR. Do we call this procedure SCR, the sign change rule? So we say it's a procedure in mathematics that we tend to apply if it is needed. We don't apply it when it is not needed. You don't see people doing CPR on each other everywhere. They apply that procedure only when it is necessary. So SCR, need to apply it. Do we need to apply it? No. There's no need, okay, to apply the sign change rule. Second question. After that, okay, we don't need to apply. Second question, is there a highest common factor, guys? Is there a highest common factor between x squared minus 81? Remember, I said when you talk about highest common factor, you think about under the banner of highest common factor sign, highest common factor number, highest common factor letter. When you are flowing with me, I can see you there. You are flowing with me. You are flowing with me. I'm just waiting for Woni. When Woni answers, guys, then I can move forward. If Woni doesn't answer, I can't have Woni cry again in my life. Never again. Okay, so the sign, yes, is a positive sign because the first term, we take the first term sign as the highest common factor sign. Number, there's a 1 and there's a 81. The highest common factor number is 1. Letter, we don't have any common letters because x squared is limited to the first term. There's no letter for the second term. Are we together? You see Sonkobe is making me cry. X is equal to plus minus 9. Sonkobe, this is not an equation. This is an expression. So we are not here to solve for x. We are simply factorizing and leaving things as they are at the end. Sonkope is looking at this, and Sonkope is thinking of x squared minus 81 is equal to 0. Guys, there's a difference between an expression and an equation. Yo, Sonkope. Okay, please take note, guys. When you are given an expression and they say factorize fully, I don't need solutions. X is equal to this or X is equal to that. You only do that if they specifically give you an equation. All right, please, people. Otherwise, you are going to cry. You're gonna cry very hard, you guys, because you are the ones that don't care. If we care more about what we are seeing, yeah. Imagine if, just because we are all girls, I just came to you and the only girl I know in the world is Sihle. I come to you, Woni, and I'm like, Sihle, how are you, Sihle? How are you doing, Sihle? Oh, it's so great talking to you, Sihle, because all girls I associate with Sihle. Are you kidding me? That is so bad. That shows my sense of lack of awareness of what is happening and what I'm doing. I'm not aware of the person that is in front of me. Imagine, you would be so hurt. Especially as someone who thinks that I know you, right? This is basically what we are doing sometimes. An expression we want to solve for x for, but an equation we want to just factorize and leave. So there's a difference, guys. This is an expression. We are just factorizing the expression. There's a difference between an expression and an equation, all right? Let's not mix up the two. There's no solutions for x here. We are just simply factorizing. Okay, so anyways, let's come back here. Highest common factor between x squared and 81. We said we took out a positive sign because of the first term being positive. We took out a 1 because between 1 and 81, the highest common factor is 1. And then later, there's no letter. So that means we have a positive 1 that we are taking out. We leave inside x squared minus 81. Then look inside the bracket. What do you see? Okay. Look at the condition. To spot a difference of two squares, 1, does what we see consist of two terms? Let's go inside. Is what is inside consisting of two terms? Yes, there's an x squared, there's an 81. So there's a minus sign, it separates. So inside we have two terms. True. 2, do terms have different signs? Does x squared and 81 show different signs? X squared is positive. 81 is negative. Yes, the terms have different signs. The last thing that will qualify, because all three things, if they are there, then we say it qualifies. It's a difference of two squares. Each term is a perfect square. Let's check. Is x squared a perfect square? Remember, what did we say about a letter? A variable raised to an even number exponent is a perfect square letter. So x squared is a perfect square letter. It has a coefficient that is 1. Is 1 a perfect square, the number itself? Yes. We move on to 81. Is 81 a perfect square number? Well, 81 is a perfect square number because it is formed by multiplying another natural number by itself, which is 9. So it is, guys. So what do we have here? Do we have a difference of two squares? Yes, we do. So what do we do when we have a difference of two perfect squares and we have identified it as such? Well, here is the procedure. Step number 1, open two brackets. Are you ready to open two brackets, my people? Let's go and open it. Let's go and open it. Open two brackets. Step number 2. Let's now put a plus sign in the first bracket and a minus sign in the second bracket. Are you ready to do that? Let's do it. Let's do it. Ceremony as we do it. Plus and minus inside the bracket. Next question. Take the square root of each term. Take the square root of each term. Then make sure you write the answers in the positions, right, that are appropriate. So, what is the square root of x squared? What is the square root of x squared? Yes, Woni, thank you so much. It is x. Okay, if you apply the square root of x, the square root to x squared, then the square root and the square, they cancel each other. Or in other words, rewritten in another way, you can write the root in exponential form. This 2 that you see here belongs in the numerator. The square root, because of its nature, the 2 for square root belongs in the denominator. If it was a cube root, you would have a 3 that's in the denominator. If it was the 4th root, you would have a 4 in the denominator. If it was the 8th root, you would have an 8 in the denominator. I hope that makes sense. So then you get an x. First term for your expression means first term answer in each bracket. Then you take the square root of 81. What's the square root of 81, guys? Whoa. Where's whoa? I want to whoa. Yes, whoa. Thank you. 9 and 9. Okay, then after you are done with that, check inside this bracket. Is there any other factorization that should be done for this bracket? The answer is no. Okay, because even if you wanted to take out a common factor of 1, that 1 is already there outside. Is there any other factorization that should be done for this bracket? This is a difference. This x is not a perfect square, but the 9 is. All right, so unfortunately it does not meet the full criteria of the 3 things that should be there. Should consist of 2 terms. Terms must have different signs. Each term must be a perfect square. That's the criteria that we need to meet in order to apply difference of 2 squares factorization. So we can't. Are there any like terms in each bracket? No. So therefore we leave our factorization there. Warning? Are we good friends now? All right. Yeah, maybe I came down very hard on you, eh? But I just felt like I looked at your comment, it just sounded like that. So if it was too much, I'm sorry. Please forgive me. Hopefully you have the heart to forgive me. Askis, I didn't mean to hurt you. I didn't mean to hurt you. I never meant to make you cry. But tonight I'm answering algebraic expressions with fractions and factorization, if you know what I mean. So I'm sorry about that. I said I'm sorry, Warnie. I never meant to hurt you. I never meant to make you cry. But tonight we're doing factorization. All right. Okay, let's move on to the next question. Yeah, Warnie. I love it. I see these are tears of joy. Your tears of victimhood have turned into tears of joy. How amazing. Thank you, Warnie. Never meant to hurt you. Are you loving my singing, by the way? Like I hope that those are tears of joy. They're not tears of, like, you know, hopefully you are being touched extremely from the recesses of your heart by my singing. It's just phenomenal. It's touching you deeply. All right, let's move on to the next question. Factorize fully. Okay, guys, we are currently doing difference of 2 squares. We've just come from highest common factor, so that's why you're seeing us doing these questions, difference of 2 squared. 4 squared minus 25. So once again we are required to factorize fully. So what do we do? Step number 1, the first question we always ask ourselves, the very common and famous question, is how many terms are in the expression? So how many terms do you guys see in the expression? Just answer that for me quickly so that we can move on to the next thing. It's 2 terms. Very good, guys. The next question we ask, is there a need to apply the sign change rule? We just quickly do that mentally in our heads. Is there a need to apply the sign change rule? So you can see there is no need at all. Third question, is there a highest common factor? And obviously, guys, we know that there is a highest common factor. We know in this case it's definitely 1. So that 1, it's really not significant. But what it does do when we put the 4x squared minus 25 inside the bracket, it's just an acknowledgement that from the 2 terms we now have 1 single term that we need to factorize. Yes, the bracket contains 2 terms, and that's why then we go to that understanding that we need to say, okay, how many terms? There are 2 terms. Are there 2 terms? To check if this is the difference of 2 squares. Are there 2 terms? Yes, they are. Do they have different signs? Yes, they do. Are these perfect squares? Yes, they are. So then what happens is that we can open 2 beautiful brackets. Then those 2 brackets, what do? We put a plus and a minus sign immediately. Then we take the what? the square root of 4x squared. Now, I know for some of you, this happens in your head almost quickly and instinctively, all right? Some of you don't have to go through the process. I'm just trying to make it common so that people can be able to answer. So we know that 4x squared is 2x, and then obviously the square root of 25, that gives us 5. So who belongs in the first position? For each bracket, it is Mr. 2x. And you can confirm, because 2x times 2x will give you back the 4x squared. Then who belongs in the second term for each bracket? It is 5. We look at each bracket. Simplify any further? No. Factorize any further? No. Any like terms? No. So therefore we end right there. We check these things, guys. You check again inside each bracket. Is there anything more that you can do? Because if you can, guys, some things will catch you by surprise. Some things will catch you by surprise. All right? So we just need to be alert and aware and alert and awake so that we don't get caught by surprise. And I know some of you are like fighting with me in your heads because you're like, hey, this guy, why is he making this long? Why are you taking, you see, me, this mentality of doing HCF and dots, it's sort of like this 2-in-1 process that I'm undergoing of basically taking out the highest common factor, making it one term, and then dots being applied thereafter, 2-in-1. Look at this. Okay, so in my head, when I standardize that and it becomes a norm, it makes me know that, okay, I need to always ask the first few questions that are fundamental. Okay, you guys do this one. I want your answers in the comment section. Let's see if you guys can do it without my intervention. Okay, let's go. 32a squared minus 98. Let's go. Let's see if you guys can follow the process. Your final answer should reflect the true final full answer. Okay, 32a squared minus 98. The question says factorize fully. If you are in grade 10, this is for you, because grade 10s are busy doing all sorts of factorization in so many topics. Whether it be exponents, that's factorization. Whether you're solving equations, that's factorization. Whether you are busy with something else, that's factorization. You see what I mean? So I am going to give you a chance. Do this one. I'm going to give you 3 minutes. It's 5:47 right now. By 5:50, everybody should have typed their answer in the comment section, and we'll see. Don't use ChatGPT. Some of you, I know some of you, you use ChatGPT, you just want to have the right answer. Guys, please, let's exercise the mind. These AI things are going to make us very lazy and unable to use our own brains and have a sense of, independent working. You see? So let's work on that. Okay, I see the first few things that my good friend is typing there in the comment section. All right, let's see names, because I see now I don't have names here. HTTP Ruben, Mr. Ruben, HTTP Ruben, Mr. Ruby. Ari is like, I never understand factorizing. Yeah, you know what, Ari? The problem is that mindset that you have. That is the initial thing that we need to work on. Your mindset, my guy or my girl, whatever you are, is very, very wrong. It won't make me type brackets. But you typed J2 into 16a squared minus 49 close brackets. How come you're saying it won't let you type, but you typed? It won't let me type brackets twice. Or it won't let you type 2 brackets, you mean? Ooh, snap. I'm sorry about that. So I'm guessing you probably know the... Okay. Let's see. I thought... But there's people who commented earlier on that typed 2 brackets. You were able to type 2 brackets. Look at this. You did this earlier on. This was you, wasn't it? 2x plus 5 into 2x minus 5. Those were 2 brackets. You were able to. So why is it keeping you now from typing? All right. Guys, some of you are victims to your mindset. Your mindset is not great because you are fighting yourselves. You know, someone who says, I never understand factorization. Do you understand that from the get-go? Like, it doesn't matter. I could try and help you, right? But now it's a battle of just you and your mindset. So me, I'm going to try and come and influence you for the better, right? But then now you are already set in your mindset that I never understand factorizing. And this thing is never understandable. I can never do it. It's never something I can ever do. Very painful mindset to be suffering under. So don't suffer under such a mindset. Please, open your mind to learning, because as long as you are still thinking like that, the answer is one is like the answer is. Oh my soul. Are you also guys having problems with the typing of brackets? I think maybe my settings there for typing are also probably standing in your way. Yeah, but I've allowed anyone to send mass comments. You guys put them in. Yes, filter comments. Okay, let's leave it up. Let's allow. I think Nongebo Mdlovu, I'm dead. What are you dead of? Okay, there. It's opened up now. I think you guys should be able to type your brackets. I see you finally did it, Mr. Who's this? Mr. Ruben. Yes, because I took off the settings that basically are limiting you guys. So it should be working now. Okay, it's letting me type it now. Very good, very sweet. Okay, I see your guys' answer, right? I see your guys' answers, all right? But I must say, there's something that disturbs me a little bit. Okay, and I'll tell you what disturbs me. All right, and hopefully when you see what disturbs me, it will never disturb me again, because you'll never do it again. So let us learn, guys. In mistakes that you make, take them as good learning experiences, learning opportunities to grow, reasons to do better next time. Okay, so let's look at this. What did I say is our step-by-step thought process? Okay, it's now 5:52. I want to now do it so that we can see the correction. Step number 1. How many terms in the expression? That's always the question we ask at the beginning. How many terms are in this beautiful expression? Okay, how many terms do we see, guys? 32a squared minus 98. We see 2. Yes, Liema, you are liemaring it. You are kokelelaring everything. Very good. Habiba, Tami, and Dinako. Habiba. Everybody is 2. Okay, good. Next question. Sign change rule. Is there need to apply the sign change rule? No. Next question. Is there a highest common factor between these two terms? Remember, when you say highest common factor, we look at the highest common factor sign, number, and letter. Sign, number, and letter. The first term, guys, is positive. So we know that the positive sign is being taken out. Number, between 32 and 98. What is the highest common factor between 32 and 98? Alright, guys, we know most that it is 2. 2 is the highest common factor, right? Then letter, a squared. The letter A is not common because it does not exist for this term. So therefore, the only highest common factor we have is positive 2. So what we are going to do, we are going to take out the positive 2. Then leave what remains. 2 times what is 32? Or in other words, what is 32 divided by 2? Then we can fill in the mess that is here. 2 times what is 32? Or what is 32 divided by 2? Yes, is 16 into a. A squared is also left, so we write a squared as a product of 16. Make sense? Why not 4? Chi Dukes is asking, why is the highest common factor not 4? That is what Chi is asking. Okay, can someone answer Chi? Because Chi is asking, why not 4? Does 4 go into 32 and at the same time go into 98? Okay, and remember, the 4 must go into 98 without leaving a remainder, my Chi. Okay? Yes, Habib. 98 is not a multiple of 4. Are we together? It can't go in Chi. So hopefully Chi ducks Chidax is getting the memo very well. Okay, so I appreciate that question in the comment section, my guy or my girl. Keep on asking the questions because we need to have the maths become clear for us. So 2 times what gives you negative 98, or what is 98 divided by 2? Right, we get negative 49. All right, that's factorization of highest common factor. So the highest common factor factorization, 2 in 1, we can see, because the highest common factor is then followed by Mr. Who? By Mr. Dots. Dots is coming in and he's like, okay, let's check if it's really difference of 2 squares. First criteria, are there 2 terms in the brackets? Yes, they are. Second criteria, are the terms having different signs? The first term is positive, second term is negative. Yes, they are having different signs. The last question, is the first term and the last term actually perfect squares? Are these perfect squares, guys? Is 16 a perfect square? Yes. 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 Is a squared a perfect square? Yes. Any variable raised to an even number exponent is a perfect square variable. Is 49 a perfect square? Yes, it is a perfect square number, this guy, because it is formed by multiplying another natural number by itself. Okay, yeah, you can put your hands together for that. That's like so amazing. So now that we know this is a difference of 2 perfect squares, what do? We bring down the 2. Guys, we don't leave Mr. 2 behind. He was there from the get-go. The minute you leave this 2 behind, it's you lose the integrity of the expression. So you can't leave Mr. 2 behind. Mr. 2 behind, 2 stays in that relationship forever. Now you guys are breaking the relationship. You know, the father of the house wants to stay outside the door and protect his family from all the robbers that will come in and break inside. Now what you are doing is you are exposing the family to robbers because the father is not staying put outside. Yabo, ATT and all of that stuff. So please, guys, don't leave the 2 behind. You are leaving the 2 behind. Your answer is reflecting just the difference of 2 squares, but the highest common factor is not there. No, guys, that's the mistake I was saying some of you were making in your comment section. Not writing the what? The coefficient. Please, if you take out the highest common, that highest common factor must be there at the end for your factorization. Are we together? Are you with me? Are you with me? Or won't you stay with me? Stay with me. Hey guys, I hope you are staying with me here, or you are together here in all of that stuff, you see. Okay, all right, now we are here, we are not together. I Uhuru, my leader, if we are not together, my leader, then it means I don't know. No, and I'll tell you this, guys, I will confess, I'll be the first one to confess, me, I am not the best teacher in the TikTok streets. And if you fail to understand me, that is not a problem. Then please, guys, you must find someone who you can hear. Please, 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 please. There's many people in the streets of TikTok and also in the streets of YouTube and in the streets of social media platforms. They will help you out. Guys, I will not be able to save everyone, unfortunately. But those who are here can hear. Hopefully, Woni, we are together. Woni, I think I was here for you today. If I can say something, I was here for you today. Anyways, the square root of 16a squared. Now, what do we say? We put plus and minus for each bracket. Remember, this is the difference of 2 squares. So we put different signs. There's this thing that says when your last term is negative, then it means that you are going to have a difference. Means different signs inside your bracket. Okay, so we put a plus and a minus sign. Then we ask, what is the square root of 16a squared? We know that the square root of 16a squared is 4a. Uhuru, can you please get off that horse of yours, my leader? That's fine. Then you can leave the live and go do past papers, my leader. You know, go and do the hard stuff. There are people who need the basic easy stuff so that they can be able to have the confidence that they need to do the hard stuff. Okay? Uhuru is saying we are not together. I thought you were saying we are not together because you are not understanding. Oh, you are not together because you want to do hard stuff. No, my leader. The basics lay the foundation for hard stuff. So let's get the basics out of the way. Then the hard stuff will come. All right. For some people, this is hard. So that means they don't understand the basics. We are trying to get the basics in. So Uhuru, please, my guy, go and practice past papers and be happy. Okay. So the square root of 16a squared is 4a, guys. So 4a for each first term. All right, because 4a times 4a will give us back the 16a squared. Okay, then that's fine, Uhuru. Uhuru, can you please, hey, Uhuru, let me do this to you, my guy. You are actually, for me, you are not a help. You are a, what you might call, you are an irritation, my guy, for a lack of a better word. So square root of 16a squared is 4a. All right, yeah. Then the square root of 49, okay, is going to give us what, guys? Square root of 49 gives us 7. Very good, very good. Beautiful. So we have a 7 here, we have a 7 there. Guys, we then look inside each bracket. Can we factorize any of these brackets any further? We can see here there's a sum, okay? But it's 4a and 7. There's nothing there. And this one, there's a difference. It's 4a, right? There's no perfect square. A is not a perfect square. 4a is, but 7 is not. So basically, there's nothing more we can do, okay? And therefore, that basically means because there's no further factorization that can be done for each bracket or any like terms that can be added for each bracket, we simply end right there. Our factorization is complete. Noneba mbubu, you now follow. Amen. Amen, sisiwe. Amen. It is just in Ineba that has allowed the you to understand. So I am very happy, sisiwe. I am very happy. Noneba, such mercy. Oh, my daughter, that name. Noneba. Woo. Okay. All right. I think. My beautiful people, yeah, this is basically where I'm going to cut it for now. No, can we get to the next one? No, I'm done, guys. Sorry. I've been here. You have been here for long. Yeah. I need to recuperate. I need to refresh. And then I will see you guys at 9 p.m. For the continuation of this thing here. All right. Habiba is like, can we do completing the square? Oh, Shaman. My favorite TikTok teacher, Sandy, so really? No, man, you are too cute, man. Too kind. That kindness, just like that. You've made my day. Because, Sandy, so you have no idea, my girl, that there have been some people who've been saying some things here. Yeah? So thank you for your comment. It means you, Danam, you. Thank you so much. Really appreciate that nice, sweet, kind words. I'll have a rest, guys, and then I'll see you later on. If you will be hopping up in the live at 9 p.m. with me, maybe it may happen that I might end up hopping on a little bit before that, maybe 8-ish, 9-ish tonight. Then I will continue, guys, with the factorization. I'll do difference of 2 squares. We'll do more factorization of highest common factor and difference of 2 squares just to expose you to more things. Then we'll do quadratic trinomial because some of you are conquering there. Some of you are conquering there at difference of 2 squares. Some of you, you are conquering there at trinomial. You see? So we'll do that type of trinomial. Because, guys, do you know what? If your factorization, I'm sure you have seen this. If your factorization, you are not safe, you get to equations, all right? Linear equations are easy peasy as well, because linear equations, guys, you did linear equations when? You did it in grade 8, you did linear equations grade 8, you did linear equations in grade 9. So you have history doing linear equations. So at this stage, guys, grade 10, you should be flowing. But don't worry, we will check these things out. We'll sort it out, innit? But please, man, when you understand something, don't just chill now and be like, I know it, and then
You think you are good. No, go practice, my guy. Practice the maths. Consistency. Do it until it is second nature to you. Like riding that bicycle. You remember the first time you ever rode a bicycle? You fell so many times at the beginning. You couldn't ride it properly. You were wobbly everywhere. But the more you rode, the more easier it became. It's like riding a bike. It's like playing a game, this thing. You are playing FIFA there. First time you are playing with the console, you are holding there, PS5. You are pressing, you are like, hey, I don't know how to do this. But what do you do in order to basically become better and better? You keep on playing, keep on playing FIFA, keep on playing the game. And then before you know it, boso ki wena. So same thing, guys. Maths is a game. We play it, you practice it. Once you understand the concept, you go grab your textbook, you practice more problems about highest common factor type, difference of two squares, until you are like, I'm locked in, I'm good. Second nature. When it's second nature, there's flow, guys. There's flow. Keep flow. Yeah, bro. Then you're like 1 + 1 is 2, and you're like snoring everywhere. Okay, guys, cheers. I am going to see you later on. Please have a good one, and thank you again for the gifts. Thank you for those that actually were able to give me those roses there. I really appreciate it, guys. 2 out of 1,000 roses for this live lesson. Thank you so much. Please, when you come later on, you can share the live with your rich aunties and uncles. Then your rich aunties and uncle can come here and they can see me do the live, and your mummies and your daddies. It's end of the month, they've paid and all of that stuff. They can come and gift me here in the live because you don't have the power and the authority to do so. They can come and gift me on your behalf. So call them later on this evening, share the live with them so that they can come and join TikTok and they can come and gift here, guys. I really appreciate it when that happens. Have a good one. I'll see you guys again later on. Like I said, 8-ish, 9-ish, right? It will be all the way up until 12 o'clock tonight, guys. We will be doing maths like crazy. Grade 10 being on fire, because match control test, guys, we are going to kill it. We're going to massacre it. It does not know who it's going to meet. It's going to meet us. All right? Cheers.